Recording in progress.
Hi students, in this lecture I am going to discuss problems. Let us see first one. Right, let us take a 3 kg block placed on smooth surface. Placing a 3 kg block on a smooth surface, and on this block placing one more. Take mass is 2 kg. Applying a force F on 3 kg block. Ground is smooth, so mu value is 0. But between the blocks, mu value 0.6. Okay. So now question is, find minimum force we have to apply on 3 kg block so that slipping starts between the blocks. Find minimum force that should be applied on 3 kg block so that slipping starts between the blocks. See how to start the problem. So first we have to focus that 2 kg block is moving only because of friction. I am taking here FBD for 2 kg block. For 2 kg block FBD, mg downwards. Take G value 10, mg 20. Normal reaction upwards. There is no motion along vertical. So n equal 20. Next, when we apply force on 3 kg block right side, 2 kg block also moves right side. Right? That means on 2 kg block, friction must be right side. Okay. So this value we have to find out. See condition now asking minimum force to have slipping between the blocks. That means to have slipping, their velocities must be different. If both blocks having same velocity, there is no slipping, right? And both are starting from rest. So here what I am doing is, when force is minimum, 2 kg block is about to slip. About to slip means friction is limiting value. So I am taking a friction is now limiting value. Why? Because it is about to slip, not slipping, about to slip. And limiting value 0.6 into normal reaction, that is 20. Okay. So 20 into 0.6. See how much we get? It is 12. So limiting friction is now 12. So on 2 kg block, net force is 12 Newton. So its acceleration of 2 kg block, that is 12 by 2, 6 meter per second square. Okay. Now coming to 3 kg block, coming to 3 kg block, see one is applied force from ground, no friction. On 2 kg block, friction is the right side. So on 3 kg block, friction is left side. It is 12. Okay. Since there is no slipping between the blocks, their velocities must be same. Okay. So I can write velocity V equal to U plus 80. Initially, both blocks were at rest. So U 0. Remaining is now A into T. Okay. So we are focusing at one instant. So T fixed. Remaining is now A. So when we are saying same velocity, its meaning is same acceleration also. Because initial velocity is 0. So V proportional to A. So equating velocities means equating accelerations. Okay. So I have to equate now accelerations. So acceleration of 3 kg block Applying force F, right side. This is 12. So net value F minus 12, that is net force. Net force by mass, that is acceleration. This acceleration is equal to 6. So why equating? Because they have same velocities. Same velocities means same acceleration. That's why I am equating accelerations. Now see from this what we can say. 3, 6, 18. 18 plus 12. 18 plus 12, that is 30. That means when we apply force of 30 Newton, when we apply a force of 30 Newton, slipping starts between the blocks. Okay, right. Now let us solve same question in a different way. Means instead of taking free body diagram for each one separately, taking as a whole. So we are asking for which minimum force slipping starts. Means up to this force, both are moving as a whole, right? As a whole means I can take two blocks as a system. So two blocks as a system means this force becomes now net force. So I am writing here net force is equal to applied force, which is equal to mass into acceleration. And here upper block moving only because of friction. It is only because of friction. So when friction becomes maximum, its acceleration becomes maximum. Okay. If acceleration is beyond 6, slipping will be there. That's why for both, acceleration should not cross 6. For limiting value 6. So 5 into 6, it is 30. So like this, directly we can solve the problem. Okay. Let us take next one. Now this time consider force is applied on upper block. Let us take force is applied on upper block. Three kg block, 2 kg block. What minimum force we have to apply so that slipping starts between the blocks. Okay. Ground is smooth. Here mu value 0.6. Okay. Right. Again, take free body diagram for each block separate. Students, if you are thorough with the free body diagram, you can solve all questions of your own. F minimum we have to calculate. When friction means when slipping starts, friction will be limiting value. When slipping starts, friction will be limiting value. Therefore, I am taking a friction force. It is limiting value, which is equal to 6, 0.6 into normal reaction 20. It is a 12. It is 12. So net force. Net force is F minus 12. Net force equal to mass into acceleration. But we want here acceleration, right? If it is no, we can get F value. Now coming to 3 kg block. See why 3 kg block is moving. It is moving only because of friction. Okay. So when we apply force right side, 3 kg block moves right side. Right. So frictional force is now right side. When this is a 12, now this also 12. Okay. So for 3 kg block, maximum acceleration is 12 by 3. That is 4. This is maximum acceleration. Okay. If acceleration crosses 4, slipping starts. So for 3 kg block, maximum A value 4 because 12 by 3, 4. Now taking this 4 in equation 1, then see what we get. F minus 12 is equal to 2 into 4. Okay. Then see how much we get. 2 4s 8. 8 plus 12, 20. So we have to apply minimum 20 Newton. Means when 20 Newton is applied, slipping starts between the blocks. Okay. Or we can say like, since both are moving as a whole up to this force, what we can do is, let us take both are the system. Then this force becomes net force. And net force equal to total mass is 5, acceleration is 6. And A value must be for 3 kg block, maximum acceleration is 4. That is when friction is maximum. So we can write directly here 5 into 4, that is 20. Okay. Like this, we can solve problems. Okay. Let us take now next problem. Next one. Now in this consider friction at both the contacts. Friction at both the contacts. Let us take same values. 3 kg. This is a 2 kg. Applying a force F. Question is F minimum to have slipping between the blocks. Here let us take 0.1. Here take 0.6. Okay. Now see what we can do. In process, there is no change except taking this one extra frictional force on 3 kg block. Okay. Let us draw once again free body diagram. For first, I'm focusing 2 kg block. For 2 kg block. 2 kg block moving only because of friction. When slipping starts, friction will be limiting value. So I'm taking a limiting value. It is the right side. Why right side means when we apply force on 3 kg block right side, 2 kg block moves right side only. It is not left side. So limiting value, it is 12, right? That means its acceleration maximum how much? Its acceleration is 12 by 2. That is a 6 meter per second square. Because net force is a 12. That net equal to mass into acceleration. Now coming to 3 kg block. 3 kg block. Applied force F, which we have to calculate. On 2 kg block, 12 Newton right side. On 3 kg block, at top surface, 12 Newton left side. At bottom contact, since 3 kg block moving right side, friction will be left side. Friction always opposes relative motion, right? How much? See carefully. At this contact, normal reaction is, it is equal to 15. Am I correct? At this contact, normal reaction, how much? It is 50. 50 into 0.1. That is a 5. It is now 5. So only change having one extra force. Right. Now net force equal to F minus 12 plus 5, 17. This is net force. Net force equal to mass into acceleration. How much we are taking? Up to 6. Both are moving as a whole. Therefore, F equal to 3, 6, 18. 18 plus 17. 18 plus 17, 35, right? Right. That is the minimum force we have to apply. Okay. If you want to solve just like a single block, why single block? Because up to that force, both are moving as a whole. In such a case, net force will be applied force minus frictional force at this contact, taking both blocks as a system because they are moving as a whole. Net force, applied force minus friction at this contact, that is 5. F minus 5. This is net force. Okay. This is net force. This net force is equal to mass into acceleration. Mass is a 5. And acceleration how much? It is 6. 5 into 6. 30. 30 plus 5. 35. So like this also we can solve directly. Is a point clear? Okay. Let us take next one. Let us take same question but apply force on upper block. Okay. Let us see. Again taking same blocks. 3 kg block, 2 kg block, applying force on upper one. We have to calculate minimum force so that slipping starts between the blocks. Okay. 0 0.1, 0 0.6. Okay. Right. So focus now. First of all, focus 3 kg block. Why 3 kg block is moving? Because it is due to frictional force. When we apply force on 2 kg block right side, 3 kg block also moves right side. That means on 3 kg block, frictional force must be right side, right? So limiting value when slipping starts. Slipping starts means friction is limiting value. That is how much here? 6. At this a contact normal reaction 20. 20 into 0 0.6. That is 12. When this is a 12, you can see at this contact, frictional force is 5, right? 0 0.1 into 50. See net value how much? 12 minus 5, 7. So acceleration is now 7 by 3. This is the maximum acceleration for 3 kg block. Maximum. Now coming to 2 kg block. Coming to 2 kg block. One is applied force. Second one, on 3 kg block frictional force, right side. So on 2 kg block it is left side. Okay. So net value F minus 12. That is equal to mass into acceleration. And acceleration is 7 by 3. Right? Am I correct? This is 12. This is 5. We got 7. 12 minus 5, 7. 7 by 3. Right. Net force F minus 12. So this is now F minimum is equal to 12 plus 2, 2 7, so 14. 14 by 3. That is our answer. So this is the minimum force that we have to apply. So that slipping starts between the blocks. Okay. Like this we can solve block on block problems.